All right. Welcome everyone to workshop number 5 on how to prepare for the quality screening process. Keep in mind that this presentation is being recorded, so we would like to ask you to keep your microphone muted and your video off. During the workshop, if you have a question on the topic or you need clarification on anything, please type it in the chat and one of our SLB members can take care of it. And just one more time, after the presentation, a copy of today's slideshow and a video of today's presentation will be available on the gsdscf.org website. We're going to get started with a few SLB introductions. So I'll go first. My name is Stephen. I'm in 10th grade and I've been doing the science fair for 3 years. So this is going to be my 4th year and I'll pass it on to Adiban.
I'm Adiban. I'm in 10th grade, and this will be my third year participating in the science fair. I'm going to
Uh,
pass it on to Jay.
I'm Jay. I'm in 10th grade, and this will be my 4th year participating in the science fair. I'll pass it on to Ashwin.
I'm Ashwin. I'm in 10th grade, and this is my second year in the science fair.
I'm Alexander. I'm in 10th grade, and this is my third year doing science fair.
I'm Maida. I'm in 11th grade, and this will be my third year doing science fair.
All right. Thank you, everyone. So, about the quality screening process, please note that it is not the same as judging. So quality screening determines whether a project is accepted or not into the actual fair. And during the actual fair, your project is judged among other projects. So this is kind of like just a qualification exam to see if your project is a good fit for this fair, if you can compete in the first place. So digital project screening is, as I mentioned, a lot like safety pre-screening, but with more details. Essentially, we just want to make sure that the project you're going to submit is within all GSD-SCF rules and is appropriate to compete in the fair. It is a last check for all the forms you need and the procedures that you performed. Your teacher has received the template for the screening slides to give to you. Please keep in mind that these slides are also available on our website and they will be distributed to you after the workshop. Please note that each grade level has a different deadline for screening. So you can see 6th and 7th grade, you guys have 10 days, so January 20th, that is your deadline. 8th grade is a week later on January 27th. And then all high schoolers, your deadline is February 11th. And then for everyone, all project resubmissions are due on February 17th. For quality screening, you're going to create a 12-slide digital presentation, which will go into a lot more detail later on. And this is just a shorter version of your project notebook, which will be covered in the next workshop. To submit, you should look on the GSD-SCF website for a template that you can copy and paste the appropriate information of your project into. Also note that project screening is not the same as judging, as was mentioned previously. Now, please note that quality screening happens only after SRC approval. So I hope all of you here today have already been SRC approved. In that case, you are free to start your project, and after you finish your project, you can start the quality screening process.
Now let's actually talk about how to create the digital presentation. So here's a brief overview of what the templates will actually look like. You're going to make one title slide and 11 slides that describe your project. It can be shorter than 12 slides, but it can't exceed 11. And the project description pages, or 11 project description pages, or it's going to be sent back to editing. You're going to start off with the title slide, then your abstract, then the background, the statement of purpose and hypothesis. Then you're going to get 2 slides to describe your procedure and include photos of the experiment if applicable. Then you get 3 slides to discuss your results, including space for graphs, statistical tests, and pictures and a summary of your findings. The next slide is the conclusion and discussion slash interpretation of your results. And then lastly, you'll end with your references. And keep in mind that this template is very flexible. So for example, if you're doing a science project, you might have more slides that are in the results section than in the methods or procedure section. Whereas if you're doing an engineering project, you might have more slides in the procedure section than other slides. And you need to make sure that all these 12 categories, all these like 12 templates are covered in the slide. So if you have like a very short hypothesis, you could fit like a hypothesis and materials on the same slide or something like that. It just has to be it just has to follow all like these rules here. Next slide. So the following 13 slides will show the actual slides for quality screening. The same template is used later for judging. You may change some information between the quality screening and the judging, but after judging, it's like before judging, it's like completely final. You can't really change anything before you're sending it off to Z-Fairs on the 27th. So after reading directions on the first slide, make sure you delete it. And on the other 12 slides, erase all the template instructions and replace it with your own information. So basically, you need to make sure that it can't exceed the slide can't exceed more than 12 pages, including the title slide, and then you can only have a maximum of two fonts that are no smaller than Arial 12 or Calibri 16. So some people who might have a more advanced science fair project or might have done a little more literature review might have more sources to state out in the references slide. So, for example, if you have like 50 sources to state out in the references slide, you need to make sure that you only state out your top 10 or the most important sources so you can actually abide by this Arial 12 font size rule. And you may not put links to, oh, previous slide. You may not put links to data. You actually need to display the data on your slide. And some information will change regarding if you're having an engineering project or a computer science project. Next slide. So this is where you would put the title, and you could put your category that your SRC has approved you for, and your first name, your name, and your grade. And then this is the title slide is the only slide you can actually decorate, and the rest of the slides must be plain with a black font and a white background.
And I would like to clarify the project title slide is the only one that you can have like if you want to do some graphic design like putting pictures or like a custom background or that stuff. For the results, if you want to put a figure there, that's totally fine, but you cannot alter the background or anything like that.
Okay, so now time for the abstract slide. So this is the first impression that people get of your project, right? So category judges and professional societies will read this first. Make sure that it's under 250 words. The website this year will simply not let you type in an abstract that's greater than 250. And here's a rough structure of it. Each paragraph must have a minimum of 2 sentences and a max of 5. Your first one should be your purpose or your problem statement. Your second one should be your procedure. The third one should be a description of results. The fourth should be a discussion. And the fifth should be a conclusion. Of course, if you're in engineering or computer science, it might be slightly different. For engineering, you might want to start off with your problem or purpose, your engineering design, the prototyping and testing phases, and the redesign and the final result and design success that's been evaluated. For computer science, you're going to start off with your objective, your development, your improvement from what's already current, sample run, and your final success evaluated. Also, there's a nice labeled abstract, and I will put the link for that in the chat, and it's a nice example abstract you guys can use.
Okay, so next is the introduction slide, which is basically starting off with your research question, problem statement, or purpose, which is what your research is all about and what problem you're trying to solve. And this should be one sentence. And then after that, you want to explain what is known in the current literature and what have already scientists been doing on your problem statement. And then you want to say like what you were trying to find out and include a description of your purpose or your research question. And then after that, you want to have a hypothesis, which is basically for science projects is a prediction of what will happen in your research or your experiment, and is slightly different for engineering and computer programs. For engineering or computer programs, it is like a design goal that describes how the solution in your project will work. And then this hypothesis should not exceed 400 words.
Okay. So a materials list is pretty much everything that you have that you used. So whether it's a survey or a chemical, um, any instruments that you needed, anywhere that you went, like facilities and big materials. It's everything that you need to complete your project is what you should be putting on your materials slide. Okay, so methods and procedure, it's pretty much the same thing, but methods and procedures are your it's how you actually carry out your experiment. It explains what you did, how did you collect your data, um, and you can also use this slide to discuss like your control group and the different variables that you tested. If you're doing engineering, you should put your engineering design and redesign in here. That way it's clear any prototypes that didn't work, um, and also what you did to fix them. And if you're doing computer science, you could use a block diagram to describe how you wrote your program. So, this should be written entirely by you. You don't copy procedures off the internet, obviously, because that's plagiarism. And lastly, and most importantly, use the metric system. Metric system is the universal scientific system. It's centimeters, liters, meters, kilograms, all that is metrics. Don't use pounds, inches, ounces. Yeah. Okay. So if you can also use photos of your design, like any blueprints or pictures of you actually doing your experiment. And if you have a picture of you doing your experiment, make sure that it's only your face. You're not allowed to use pictures of other students, and if you're doing a human testing, you're not allowed to use pictures of the participants that you used. Um, if you have like a parent that helped you out, you can ask them for permission to use their face in the paper. If they say no, then obviously don't. And yeah, there's that.
Okay, so now we're gonna go over like the results of your project. So the results is kind of how like what was like how did your experiment end and like what happened during your experiment? Like what trends did you notice? So to illustrate them better, you want to include tables and figures which like illustrate all your data. So commonly in the results section, you're gonna have a lot of graphs. So make sure you like label your graphs appropriately. Like make sure you have all the X and Y axis labeled as well as a title so that like people can understand your graph and what it means. And the most common type of graphs that you see in the results will be like bar and line graphs. So line graphs are representing like change over time. So you could think about like plant growth typically, or even like like density of a like certain compound over time. And all other data must like often has to be demonstrated with a bar graph. So bar graph is like often not over time, so just keep that in mind. And sometimes people put pie graphs and charts, but they're generally not used for most science fair data, so just keep that in mind. And make sure you only include the relevant statistical analysis of the data. So this could mean the mean, percent change, and you could put standard deviation, error bars, chi-square. And if you're doing like a computer science project, you could put like sensitivity and like recall and all that stuff. And for engineering, um, you want it to be evidence of design, test, redesign, and a successful prototype. So yeah, make sure to um, keep that keep that in mind. And then another thing that you need is the number of trials and sample size must be evident. So if you're like doing like an experiment, you just want to like, you could maybe like start with the number of trials and the sample size you use. So yeah. And then for computer science, you want the description of success of a program. So like you could talk about like how it finally worked. And yeah. Okay, so you pictures of results and designs, if appropriate, are like highly recommended because it really it's really reflective of your results as a whole, and it's like pictures are really helpful for results because they're easier to interpret than if you just like were to just write about your results. And it is important to have like a short summary of what happened, like any results, design success, or program success. So make sure you do include that in there, but it's great to like have pictures alongside so it's easier to understand. And you also need to make sure you compare your control with your experimental data. And if it's applicable, you should include maximum and minimum values. So like how much variability did you have in your measurements? And if you're like doing, um, if you have like some raw data, some pictures of it or like sample pictures from your notebook could also really be helpful. Okay, and then any additional results information you can put on this slide because if you do have like a lengthier like test procedure, you might have more more like figures to show. So just keep that in mind. And then also always include like a brief description of the graphs with trends and patterns shown in the graph. So make sure you have that if you're like just like make sure that you interpret your figures in some way and also make sure all of your figures like are on the slide itself and you don't have to like press a link to like see the image. So make sure all of your images are on the slide itself.
Okay, so next is the discussion slides, and discussion is basically the interpretation of your results based on the literature and published data. So you want to discuss your data with these research articles, and you want to say what these results mean, and then afterwards you want to discuss the possible errors that could have occurred in your research project or engineering and computer science project, and if there were any questions or problems that arose that you were not expecting. And then you want to explain how the data varied between repeated observation of similar events and how like uncontrolled events could have affected your results. And then for engineering projects, you want to explain how and why did you make your changes to your design version to reach your engineering goal. And for computer science, how and why did you make changes to the computer code to reach the programming goal?
So next we're going to talk about the conclusion slide. So the conclusion and discussion are a bit different. Basically, the discussion is where you think and where you actually like combine the ideas, but the conclusion is where you decide and like state the final answer to the research question and say whether the hypothesis was actually supported or not, and summarize implications and like next steps. There should be no new analysis or literature review, and it should basically just tie into the previous information that you stated out. So, and then you just talk about if your hypothesis is like supported or not. And then, um, for an engineering project, it's basically how does your design perform in comparison with other existing design? How's your like the model that you created, how is it any better than existing previous methods that exist that are functionable? And then for a computer science project, it's like how does your program better in comparison with any other existing programs? Um, how is it more applicable for the project you're doing? And then next slide. This is the references page, and this section it shouldn't exceed more than one page. and it should only be limited to the list of your most important references. You could list like references like documentation, like research papers, journal articles, and it's permissible to include a short statement where you acknowledge support from your supervisors, research groups, and others that actually had a direct role in your project. And you should have one citation format to use throughout, like an MLA format or APA formats, some format like that. But you should be consistent with the format you're using. And the font size still applies to this.
All right, so now we'll be going over submitting your project for screening. So the website is new this year, so it's going to be a little bit different. After you've been SRC approved, go ahead to the website and log into your account. If you go to tab 6, which should be titled Digital Presentation Upload, it should be highlighted because that should be the next step for you. And then you can download the digital presentation template, and that will be a PowerPoint. But when you fill out the digital presentation template, like change it for your project, adapt the template and different slides and stuff, be sure to convert it to a PDF. The website only accepts PDFs. So after that, you'll have your digital presentation template, digital presentation that's final, and you'll convert it to a PDF, and then you'll upload it using the button Upload File, and then you can click on the button to submit to quality screening after you look over it. So here are some example screening slides. I'll be pasting the link to both of these in the chat. Okay. Next slide. Okay, so you basically get 3 results back from screening. If you're not accepted, that means you can't apply, so we'll see you next year. You can be accepted to apply to the fair, and then also you might be chosen to resubmit with modifications. They might decide that your project seems fine, but there's some small errors or stuff that needs to be fixed. And then also be sure to monitor your status, right? Because I believe there's a deadline. There's a deadline for resubmitting project modifications. So if you go to my account, my projects, status, and also you should be notified by email when your status changes. So be sure to be active on both of those.
Sorry, I was muted. But as I was saying, please don't worry about this project. Screening is just to make sure that your project is following all FAIR guidelines. It is not a metric of how your project is going to perform. It is just a metric of if you're going to get into the fair or not. So please submit it by the deadlines, and it will make life easier for everyone. So one more thing, the screening should be completed when your entire project is finished. So for screening, you're putting all the data from your entire completed project onto these slides. It's not like your project is partially completed or anything. Please make sure that you have fully completed your project when you submit to quality screening. As always, we have a couple future workshops. The list is getting increasingly smaller as the year goes on, but on February 14th, we will have our workshop number 6 on the science fair display backboard and notebook. This upcoming workshop is, with this one, probably one of the most important workshops that we offer. So we highly recommend that you go to workshop number 6. And then on March 7th, I think 2 weeks before the fair or so, is our in-person science fair judging practice. More info to come on that soon. And finally, after the fair, we will have, as always, a post-fair workshop. If you have any questions today that have not been answered, please email gsdscf@gmail.com. And if you are still interested in joining our mentorship program, it's never too late to sign up. Just I'll be sending that forms link into the chat in just a minute. That's all we have for you today. Thank you so much for coming. We hope to see you at the next workshop. And I will stop the recording.